Veronica.
And I'm Brittany Greer, and this is Rosie Riveters. We know all of you guys are stuck at home and wondering what to do, so we figured that we would try to virtually bring you some science experiments. We're gonna upload as much as we can, right? Things are kind of crazy when we're homeschooling our kids and trying to do our jobs. But we have Gracie joining us virtually from her house on FaceTime, and Veronica's obviously here with me. I'm gonna post all of the materials that we use in these projects. If you've got stuff, awesome. I'll also give some suggestions for alternative things that will do the same, provide the same outcome, just using different material. The pepper in the water simulation of dirt on your hands and how soap works, running around Facebook and all other social media platforms. And it's a great visualization of how soap helps get rid of dirt. But we're gonna dive in a little further behind the science of how that actually works. So just to recap, in case you haven't seen it, we're gonna take a look. Veronica and Grace, I'm gonna put pepper into this water. Regular ground pepper, okay? So I have a dish with water, and I put some pepper so that it floats onto the surface. Grace, I'm gonna pick you up so you can see again. The pepper is representing our dirt. So Veronica, can you take one finger and put it into our pepper dirt? Right, now take your finger out. What's on your finger?
Water and pepper.
Yeah, so pepper dirt. Okay, now I want you to take a different finger and put it into our liquid dish soap that's sitting in the cup. Right, coat your finger. And now very, very gently, with a finger that has soap on it, touch the top of the pepper. No, in the water. Did you see that, Grace?
Yeah.
What happened, Veronica, when you put the soap into the pepper?
It moved away.
It moved away, right? It created what we're gonna talk about as space. So let's break it down, right? We learned about soap. Soap takes off dirt. That's great. It's important to wash your hands. But how does that all work? So girls, if I told you, which you've heard me say a million times before, right? That the whole wide world is made up of molecules,
which
right?
is my favorite word.
You could also break it down to atoms and particles and things like that. But for them, everything we interact with is made up with molecules, right? So if I ask you to tell me, and this is a bonus question and see if you know it, what are the 3 states of matter? What are the 3 types of stuff we interact with?
Liquid,
right?
solid, and gas.
Liquid, solids, and gases, right? And liquid, solids, and gases are formed by the way different molecules are arranged. So what do I mean?
Right.
So here's our picture. I'm gonna post it in the comments, but I want both of you to take a look at this. Do you see solids, liquids, and gases, Grace?
Yeah.
Veronica, do you see solids, liquids, and gases?
Yes.
What can you tell me that's different between this? These are the molecules. What's different between the solid molecules and the gas molecules? Yes.
Here is the molecules are going together, and the solid molecules and the gas molecules, they're all spread apart.
Yeah, Gracie, can you see that?
Yes.
What's different between the liquid and the gas versus the solid?
Versus the solid, liquid and, some of the liquid molecules are connected in 2.
Okay, yeah, so they're a little bit further apart, right? So let's think about this with water, okay? When water is a solid, what is it?
Ice.
Ice. When water is a liquid, it is, I gave it to you already.
Molecules.
It's water, right? It's kind of a trick question. And when water is a gas, what is it? Do we know?
I see some molecules.
When we make pasta on the stove, right, and it heats up, what comes off the top of the
Pasta.
What comes out of the top of the pot?
Fire. No, smoke.
It's kind of like smoke, but it's not smoke. It's what?
Smoke.
Smoke. So it's actually not smoke, it's steam. So it's the water evaporating. So the particles are moving in a different space. Okay? So we know that the states of matter are solid,
Liquid, and gas.
liquid, and gas. Now
And
here's
molecules. They're all
a
made
fun
of
one.
molecules.
Okay? So the whole wide world is made up of molecules. They can be in solids, liquids, and gases, right?
And anything different.
But the solids, liquids, and gases, right, behave in different ways. They have what are called different properties, right? Gracie, I'm going to turn you towards the camera first. Okay? So, who can tell me what a property, how does water react if you pour it from one container to another? If I take this water right? Grace, if I take this water, or your water bottle, or your soap, and I poured it from here into here, what would it do?
Spray it.
Would it be the same shape as it is now?
No.
No. Would it be the shape of this?
Yes.
Yeah. What if I poured it into here?
It would
It would be a cylinder shape.
It would change a different shape. And I can pour it, right? I can move it this from here by pouring it from high to low, right?
You know what you
Which is pretty cool. Hold on, we're gonna do that in just a second, right? So one of the properties of a liquid is that I can pour it from high to low, right? Which is pretty cool. Now here's a bonus one. Are you excited? This is where we get to do fun science.
Sure.
Okay, so Grace, can you see what we're doing here? Can you see the pennies?
Yeah.
All right, so we are gonna take regular water, which has a bit of pepper in it, but it's all good in the hood. Regular water in our pipette, right? And we're gonna have Veronica drop as many droplets as you can onto the top of the penny. We're gonna count. Grace, you think you can count with us? Can you see the water?
Yeah.
1, 2, 3, 4.
4, 5,
Oh, wait. 5,
6,
7, 8, 9. Now pause. Veronica, take a look at that penny. What do you see? Do you see the water, Grace? Can you see how it's...
Yes.
Is it flat on the penny?
No.
No. What does it look like?
It's like a dome.
It's like a dome, right? So the water molecules are holding on to each other. So one of the properties of water is it has something called surface tension. Can you both say that?
Surface tension.
And you know the easy way to remember surface tension? Surface tension is when the water molecules hold hands. Okay?
Like they're
Hold your
holding
hands
hands
together,
together.
Grace. You got one water molecule and two water molecules. And you put them together and they hold hands. Okay? So they have surface tension. They hold together. They try to hold together for as long as they can. Now look what happens when we add soap. Okay? So I'm going to put some of this water into our soap, right? Just like we did before, kind of when we looked at it. Now Veronica, with the soapy water, how many drops did we have?
9.
9. Okay, now take your soapy water and try again. Watch that penny, Grace. Ready?
Yeah.
1. Oh. Go. 2, 3, 4, 5, 6. And it's right off the side. Did it run all over the place?
Yeah.
Yeah. Now we have a wet table. So here's what the soap does, right? Was it able to hold on as tight when it was with the soap? No. So the soap made the water let go of each other's hand. So the water molecules are still there, but they're not holding as tight. So here's the best thing. Soap, you know what soap does? It makes...
Reaction.
No. It makes space, okay? Soap makes space for other things to come in. So the same way when we stuck our finger into the pepper with the soap on our finger and all the dirt moved away, it made space in the water, yeah? And that water means that the soap can get in and the germs can come off and it's easier for them to come off of our hands. Cool? All right, and we're going to pour a little bit of milk.
I already have milk.
And your thing. Okay, so you're gonna be ready to go. So we're gonna pour a little bit of milk in here. Help me, Bee. Okay. You don't need a ton of milk. I know people are saving their milk. You can use a smaller dish than this. This is just so everybody can kind of see what we're doing. But you only need a little layer, like just to cover the bottom of the pan, really. Full fat milk works best, but you can really use any kind of milk to make this work. And then what else do we have to have?
Food coloring.
Food color. So we have a few colors, right? And then we're gonna take some soap, right? And we're gonna put it into a container so we have it available. I want you to take one of each of your colors and make 1 drop in your milk, okay?
Just one. This is important, okay?
So why wouldn't we want to put all the colors in at once? What happens if we mix all the colors
It
together?
turns dirty.
It turns brown, right? And we want all kinds of cool colors. Or brown's a cool color, but we're gonna keep them separate for right now. So open up your container, yep, and put 1 drop of each color into your milk. When we put our finger in the pepper, right, our finger got covered in pepper. But when we put our finger with the pepper in that had soap on it, what happened to the pepper?
It pushed away.
It pushed away, right? It made space. So when we put our, here you can use this one, we're gonna pick up our soapy Q-tip and we're gonna touch the color and I'm gonna tell you what's happening. So touch it, try your other one, try all 4 corners now. See what happens as they go to the middle. Okay, so one of the things that makes up milk, which is a liquid, is fat, right? So there's lots of fat, particularly in whole milk, which is why that works the best. The soap comes in and just like it made space in the water for the pepper to move, it made space and it moved the fat molecules. Now when it moved the fat molecules, what took up its space?
Milk.
What moved in when the fat molecules moved away? What moved all over the milk? The colors, yeah, exactly. So where the fat molecules used to be clumped together, they opened up and that color moved through. Now, if you have watercolor paper at home, you can try to move your colors onto your watercolor paper and make a tiny pick, straight up, pick it up, straight up, and make it look like that, right? So it's able to transfer the creation that you made in the milk, which is pretty cool. Regular paper tends to disintegrate, but you can find all different things at home that you might want to experiment with. You can try paper towels. You can try cardboard. What else do you think you can try, Grace? What else could we dip in the milk?
I'm making something very cool in my milk of dish.
Ooh, I like it, right? So maybe you can try coffee filters. Let us know, right? Try different things. Tell us what worked. Tell us what didn't work, right? Science is experimentation. Some of things are going to be total fails. Some are going to be amazing successes. We want to hear all of it. As we go through this process, we're going to try different things. We're going to try a Facebook Live. We're going to record more videos. If your kids have an idea for an experiment that we want to share with others, we'd be happy for you to join us via FaceTime. So let us know. We're all in this together. We're going to give you the best resources we can. We're navigating working from home as well, but we're all going to do this. So any questions you have or advice you need, let us know. Yep, Grace? Wow! Look at Gracie's!
Nice.
Gracie, what did you dip? Is that your milk?
Yeah.
It's beautiful. You want to see Veronica's?
Yeah.
Take a look.
Pretty.
Pretty. And then these are her papers. The cool thing, right, is once you dip those papers, why don't you send a letter to your friend, right? Or decorate your room, or let Grandma and Grandpa know of some of the projects you did while you were making milk art. All right, girls, can we say to everybody what we always say at the end of a Rosie Riveters project?
We can do it.
We can do it! We're all in this together and we're all gonna get through it together. So we can't wait to see you guys soon. Send us your questions. We'll also have some story times available, but if you have any other things you think you'd like to see from us,